The next step in stoichiometry is getting to something a little more realistic, and that's dealing with grams. Moles are nice. They are easily found through the periodic chart as to the number of grams in one mole. But when your equation deals only with molecules and moles, grams are not mentioned in that. In fact, they never will be mentioned in that. In order to figure out grams, you have to figure out the number of moles that you have. So the relationship we're going to be looking into today in the equation is the relationship between the moles speculated in the problem, in the balanced equation, with the actual number of grams that they are describing. All right? So, let's take a look at this equation, the formation of ammonia, also known as the Haber process, which is something we really get into in Chem 2 if you're lucky enough to take it. Okay? Now, remember, this deals only with molecules, moles, but not grams. This does not say that 1 gram of nitrogen will react to 3 grams of hydrogen, give us 2 grams of ammonia. That is not what it's saying. It is saying that 1 molecule of nitrogen reacts with 3 molecules of hydrogen to create 2 molecules of ammonia, or it is saying that 1 mole of nitrogen reacts with 3 moles of hydrogen to produce 2 moles of ammonia. It is saying that, but grams are not in that scenario. So we have to use the moles to get to the grams by using our friendly periodic table. Okay, that was pretty good. So, let's suppose that we have 50.4 moles of ammonia. I'm sorry, let's make it 5.04 since that's the number I'm supposed to have on here. 5.04 moles of ammonia, right. And in a calculation, I get this for an answer, but again, I want grams, I don't want moles, so I simply have to change that to grams of, oh, I see here. I want to know how many grams of nitrogen are going to be created from that, or how much are going to need. So, how much ammonia, how many grams of nitrogen am I going to need to create 5.04 moles of ammonia? Okay, so we start with 5.04 moles of NH3. Now, and I want to change that to nitrogen, and I want to change that to grams. Unfortunately, when we do conversions, we can only change one of the 2 things. So we have to go to moles of nitrogen to figure out how many moles of nitrogen we have, and then change that value to grams using the periodic table. So I'm going to put moles of NH3 on the bottom, and put moles of N2 on top, which I can do by using that up there. We're going to get to it just a little bit, but I want to take care of the labels first. We know that moles of ammonia will cancel out. And then we're going to change moles of nitrogen to grams of nitrogen using our periodic chart. Our periodic chart. All right, so let's go to this. When you go from moles to moles, you are using the equation at the top. So the numbers, the coefficients in the equation, nitrogen, the number in front is 1, the number in front of ammonia is 2, so we have a 1-to-2 ratio for that. Now, since I'm changing moles to grams, that's where I'm using the periodic chart. And realizing that all the numbers on here represent for 1 mole. So we always have 1 mole when we use the periodic chart. The grams, now it says N2, not N, but N2. So that means we have to double the nitrogen here. Nitrogen here is 14.0. Double that, we get 28.0. So on your calculator, you're going to take 5.04 divided by 2 times 28.0. And the answer we get for that is 70.6 grams of nitrogen. Okay? Next up, we're going to go from 26.5 grams. Now we're going to start the other direction. We're going to start with grams of nitrogen. And I want to know how many moles of water are going to be produced from that. So again, we start with 26.5 grams of nitrogen. But I have to change the grams of nitrogen to something that can be changed to moles of water, and that'll be moles of nitrogen. So I put grams of nitrogen on the bottom and moles of nitrogen on top. So the grams of nitrogen cancel out. So I changed the grams to moles, but I left the nitrogen alone. Remember, every conversion, only one thing can change, either the label or the substance, but not both at the same time. So look for that when you convert. Now I can change moles of nitrogen, put that on the bottom, and I want to change that to moles of water. And because of the moles being converted to moles, this is going to come from the equation on top. I cancel that out right there. Now, moles of nitrogen to grams of nitrogen, we just did that in the previous problem. We said that 1 mole was 28.0 grams. Moles of water to moles of nitrogen. Moles of water is not the problem. Wow, I don't have nitrogen. That's supposed to be, let's say, oh, that's supposed to be hydrogen. Yeah, there's no water in the equation, so that'd be kind of difficult to do. So we go to moles of hydrogen. How many moles of hydrogen do we have? So moles of hydrogen, which is 3 moles of nitrogen, which is 1. So 3 by the hydrogen, 1 by the nitrogen. And now we have 26.5 divided by 28 times 3, and we get 2.84 moles of hydrogen. Our answer. Okay? Let's do a couple more just to make sure we got this down. Let's take a new reaction, new equation, the burning of propane, C3H8 liquid. Actually, that's a gas. It comes in liquid form, but when it gets piped into the house, it's a gas. Plus 5 O2 gas yields 3 CO2 gas plus 4 H2O liquid. And let's start with 21.8 moles of oxygen. And I want to know how many grams of water are going to be produced from that. Okay, so we start with what we're given here, 21.8 moles of oxygen times fraction line. I'm going to get rid of the moles of oxygen, but the question is, what do I change that to? Well, I know I want to end up with grams of water, but I can't get grams of water from moles of oxygen, but I can get grams of water from moles of water. And I can change moles of oxygen to moles of water using the equation right above us, which I'm not going to do yet. I'm just going to get the labels taken care of. Now I can change moles of water to grams of water. And now the moles of water will cancel out, and that gives us what I want. So we start off here. When I go from moles to moles, that's dealing with the coefficients, the stoichiometry of the equation. Water has a 4 in front of it. Oxygen has a 5 in front of it. Over here, the grams of water is coming off the periodic chart, and these all represent 1 mole, so anytime we go off the periodic chart, that will always be a 1. That's something that a lot of people miss. They're going to say, oh, look, water's got a 4 there, so a 4 belongs there. Nay, 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 I say. That's only when you're going from moles to moles involving water. When you're going from moles to grams, it's always 1 mole. Now hydrogen's 1.01, and we got 2, that's 2.02, and oxygen's 16.0. We add that to that and round out the 3 sig figs, 18.0, which most of you already know because of the nauseating number of times we had to do that in the hydrates. And now we're ready to go. 21.8 times 4 divided by 5 times 18.0. And the answer we get for that is 314 grams of water. Okay, let's do one more problem with that, and I think we're ready to rock and roll. We have 0.850 grams of propane. And I want to know how many moles of carbon dioxide are going to be created from that. So we start with 0.0850 grams of propane times fraction line. Now grams of propane has to be changed because if we're going to use the equation up there, it can't be done in grams, we have to change it to moles of propane. And as you can see, the propane stays the same, but the grams gets changed to moles, which we can do, but not just right now. I'm just going to go ahead and cancel that out right there. And then we're going to multiply it in this fraction. Moles of propane on top means you have moles of propane on bottom. And then we want to change that to moles of Cl2. That's the ultimate goal, which we can do because we can go from moles to moles using the equation at the top there. This cancels out. All right, so we go ahead and plug in numbers here. If we're using the periodic chart, we know that this is always going to be 1 mole here, no matter what it says on top. It has nothing to do with that. It has everything to do with the periodic chart. These all represent 1 mole. Carbon's 3 times 12.0, which is 36.0. Oxygen's 8 times 1.0, 1, which is 8.08. And to add those together, round out 3 sig figs, we get 44.1. Then we have 1 mole of carbon dioxide, and the propane come from up here. We have 1 for the propane, and the carbon dioxide's got a 3 by it. So that means we put a 3 by the carbon dioxide and a 1 by the propane. So now we take 0.850, divide by 44.1 times 3, and I have here 0.580 moles of carbon dioxide. So that's how we do the conversions from moles to grams or grams to moles using stoichiometry. Our practice problems are found on Google Classroom as a separate entity, so you need to get that and download that or take a look at that or copy it down, whatever, and then do your problems. Have fun!